In this video, students will learn how to find the inverses of exponential functions algebraically and graphically. They should already know the basics of exponential functions, logarithmic functions, and how to graph both. They should also know that inverses are functions that reverse effects of each other. Essentially, the x and y values are switched, resulting in a reflection along the line y equals x. To begin, we'll start with reviewing exponential functions. The standard form is f of x equals a times b to the x. In this form, b represents the base, x is the exponent, and a is the constant that is multiplied by the quantity of b to the x. In this function, the domain is negative infinity to infinity, and the range is 0 to infinity, with an asymptote at y equals 0. Also, in this function, b has to be a positive integer other than 1. To review logarithms, the standard form is f of x equals log base b of x. Here, b also represents the base, but x represents the argument, or the number that results from the base being raised to the unknown exponent. In this form, the domain is 0 to infinity, and the range is negative infinity to infinity, with an asymptote at x equals 0. It should also be noted that this function can be read as b raised to what power equals x. You will now see how you get to a logarithmic function from an exponential function. Assuming that a equals 1, this is the standard exponential function. In order for ease of operations, we're going to change f of x to y. So we get y equals b to the x. Now, to perform the inverse operation, you're going to switch the places of the x and y. So you get x equals b to the y. You want to isolate the y, and to do this, you take the log base b of both sides. So you get log base b of x equals log base b of b to the y. Because you understand the properties of logs, you should know that this side can be simplified to y times log base b of b. And you should also know that the exponent required to raise any number to equal itself is 1. So this side essentially means y times 1. Because we know that, we know what this function means. Y equals log base b of x. To change it back into proper notation, we're going to change it to inverse function equals log base b of x. We will now see other examples of how to solve exponential equations.
Now let's look at the parent graph for one of the parent functions for exponential. So f of x equals 2 to the x power. Now we know that the asymptote for that graph is going to be at y equals 0. So, because y can no longer be smaller than 0. Now some of the points on this graph are going to be 1, 2, 2, 4, and 3, 8. That's if you just insert values for x, you get x. You get y. So 0, 1, 1, 2, 2, 4, and 3, 8. So the graph for that looks something like that. Now we'll take the inverse of that function. So we know that 2 is going to be the base of the logarithm. So we're going to take the log of both sides. So it'll be log base 2 of x. Will be the inverse of f negative 1 of x. Now, let's look at some of the points for that function. So if we insert 1 in for x, we're going to get an output of 0 because 2 to the what power is equal to 1, output is 1. So one of the points on that is going to be 1, 0. Now, 2 to the second, 2 to what power equal 2, so that would be 1. So it would be 2, 1. Now, 2 to the what power? What's the next power 2 that we know is 4? So 2 to the 2 to the second is 4. So it'll be 4, 2. And then the next power 2 we know is 8. So 2 to the third is 8. So 8. So we'll put the points for there. 1, 0, 2, 1, 4, 2, 8, 3. Now we know that there has to be an asymptote on this graph. And that asymptote is going to be at x equals 0 because, knowing the definition of a logarithm, we know that the b and the x value cannot be less than 0. So x cannot be 0, so the asymptote is at x equals 0. Let's read it. That means the function is going to look just like that. Y equals 0 is the graph. So now that we know through the definition of an inverse, that if it's an inverse function, that the x values will become the y values, and the y will become the x. So we can see that here with 1, 0, 0, 1, 1, 2, 2, 1, and all the way down, and the asymptotes are also flipped.
Next, we're going to look at an example. We're going to take the function f of x equals 3 to the x minus 1 plus 2, as shown here on the graph. So, you can see that it has an asymptote at y equals 2 and some points along here. So, first we're going to find the inverse algebraically. So we're going to set y equal to 3 to the x minus 1 plus 2. We're going to switch the x and the y values. So x equals 3 to the y minus 1 plus 2. We're going to isolate the entire y term. So x minus 2 equals 3 to the y minus 1. As shown earlier by Erin, we're going to take the log of both sides. So we're going to do log base 3 of x minus 2 equals y minus 1. And then finally we're going to completely isolate the y. So now that we have the inverse of f to the negative 1 of x of log base 3 of x minus 2 plus 1, we can graph that here. So as you can see, it has a asymptote right here of x equals 2. And then if you highlight some of the points, you can see that there's the x and y values appear to be reversed, like 5, 2, and 2, 5. So as well, if you take a look at the line y equals x, all the points on the graph and the graphs themselves appear to be a perfect reflection over the line y equals x, which is another definition of inverses that you learned in the inverse video.
So in conclusion, you should now be able to know how to graph and solve a logarithmic function given an exponential function. So if you look at a function, no matter what, a logarithmic function, no matter what it is, so let's just say f of x is equal to the log base smiley face of frowny face minus 7. So you should read that as smiley face to the what power is going to equal frowny face minus 7.